สวัสดีครับผมสัมภาษณ์คุณธรรมจากบริษัท WAD เทคโนโลยีประเทศไทยนะครับวันนี้ผมรู้สึกยินดีและก็เป็นเกียรติที่ทุกท่านได้ให้เกียรติเข้ามารับฟังการสัมมนาเกี่ยวกับการศึกษาการพัฒนาเกี่ยวกับสัญญาณ 5G และการสื่อสารผ่านดาวเทียมนะครับโดยบริษัท WAD ของเราเนี่ยเป็นพาร์ทเนอร์กันกับบริษัท TMYTEK ที่ไต้หวันนะครับโดยหลักๆของเราเนี่ยเราก็จะทำเกี่ยวกับFTTX Cable TV Wi-Fi Network CCTV แล้วก็พวก Smart City แล้วก็ 5G นะครับโดยวันนี้เนี่ยเราได้รับเกียรติจากมิสเตอร์อีธานซึ่งเป็น Vice President ของบริษัท TMYTEK ที่ไต้หวันจะมาให้การบรรยายในครั้งนี้เพื่อไม่ให้เป็นการเสียเวลาเชิญรับฟังการบรรยายจาก TMY ได้เลยครับ
Okay, Tam, thanks for the introduction. I'm Ariel from TMYTEK. Today I will be the host assistant. Welcome all to join in the webinar. Before starting, we would like to remind you to mute the microphone during the course for an enjoyable course experience. Okay, then now we are going to introduce today's topics. It contains 3 sections, including the introduction of IIoT and satellites, mmWave beamforming platform, mmWave solutions and video, and then we will move on to the live demo presented by TMYTEK Vice President Ethan Lin, and finally the 5 minutes QA session. The course will be presented to you by the recorded video, and Ethan Lin will demonstrate the live video session for you. Let's begin the course video.
Hi, my name is Ethan, the co-founder and the VP of TMYTEK. Today, it's my pleasure to introduce our 5G mmWave developer and educational platform for IoT and satellite communication, the true vision of 5G network, enhanced mobile broadband, mission-critical control, massive IoT. All these 3 goals are the true vision of 5G network. To achieve the true vision, there are steps defined by 3GPP. Before release 15, people focus on mobile broadband. Since release 16, more focus is on industry expansion, including ultra-low latency and IoT solutions. So today, 5G technology evolution driving private network and IoT. In a factory, or as we call smart factory scenario, enhanced mobile broadband helps the transmission of the VR or AR videos to help the operators online. And the massive IoT is essentially a lot of sensors will be installed in the factory to help to collect data. An ultra-reliable low-latency network is necessary for AGV, that stands for Automated Guided Vehicle. All this will form the fundamental of smart factory. So private network and edge computing drives IoT. There's a lot of applications and scenarios we really need a mmWave and a 5G network, including low latency collaboration, digital twins, and even real-time asset tracking. Edge computing reduces latency between the local gateway and local core network. So 5G network plus edge computing will enable the true power of the IoT. This is a global spectrum in addition to 5G. Millimeter wave technology is also focused pretty much by low Earth orbital constellation. So satellite communication is definitely the next big thing. High throughput satellite, mobile satellite services, and rural area connectivity. All this will need millimeter wave technology to be involved, especially those large array antenna. That is the key. Yes, large phase array. Let's look at the phase array used by SpaceX and Amazon Project Kuiper. All these large array are in millimeter wave band. Yes, millimeter wave and array antenna are so crucial. That's a key technology for 5G and LEO. Let's look into more details about array antenna and the beamforming. Beamforming is essentially the key technology for 5G new radio millimeter wave. So array antenna, that's the key feature number one. Consequently, beamforming is also another key technology to deliver robust non-live-side connectivity, to support seamless mobility, and to complete the macro area coverage. Yes, beamforming is so important. As above, I mentioned 5G millimeter wave is important and definitely will have a great impact to this world. To enable 5G millimeter wave, there's a lot of development work need to be done. TMYTEK, we believe this world deserves a great tool. So to help all the company and the university to step into 5G millimeter wave field domain, we build up the developer kit to include beamformer, amplifier, signal source, power detector, and more. We believe the kit will help you to getting started. The developer kit including 8 major pieces. From a specifically designed COCO antenna, covers from 27 to 29 gigahertz, and the amplifier. The frequency range is from 20 to 40 gigahertz. And array antenna supports N to 57 band with a 50 dB gain. And the B-board, that's the youngest brother of our beamformer family, to support N to 57 beamformer. The kit also supply RF cable to run up to 40 gigahertz. One power detector is included. It's 0.1 to 40 gigahertz with 35 dB dynamic range. Furthermore, we also even provide a signal source implemented by phase lock oscillator PLO technology to cover from 26.5 to 29.5 gigahertz with 8 steps. Finally, we even ship with a power combiner to support both from 15 to 40 gigahertz with a 1.2 dB loss. All this kit will definitely help you to unleash your creativity in millimeter wave area. A GUI, yes, we built a GUI ready for you. You can use the GUI to control the devices easily. More details will be in our lab cookbook. The developed kit is great for both the educational and the development purpose. So here I'd like to introduce Field Lab TMYTEK we already built up for you to show you how this kit can help you to educate next generation RF engineers. The function block for Lab 1, gain measurement, showed up here. The signal source is provided by PLO, and a 28 GHz signal has been fed into B board through an RF cable. Then another RF cable will connect between B board and the power detector. With a simple architecture here, it can be easily to measure the power out of B board and compare the output of B board and the input from PLO. As easily the students can calculate gain. That's how gain measurement is being performed. Here shows the result. The power being measured by our power detector is very close to a commercialized version of power detector with a super affordable price. Even better, everything is in one kit. We just built that for you. That's very, very convenient. And the result is very good. So with calibration of the offset, the student is going to have a great power detector to measure the powers out of B board. Based on the fundamental we built up in the Lab 1, in Lab 2, we're going to demonstrate how constructive and destructive interference happen. Constructive and destructive interference is basically the fundamental, and it's basically the magic behind the scene of beamforming. Again, let's revisit the architecture and the setup here. This time, we attach antenna to B board and attach cocoa antenna to the amplifier before the signal is entering into power detector. With the architecture here, we perform OTA testing. So you can imagine, with such an affordable components here, you can see how beamforming is happening in real life. That's really an affordable system. With the architecture here, there are 4 channels out of B board. So what do? We adjust one of the channel and make the measurement. So what do we adjust for one channel? We adjust the phase. So whenever the phase of channel 2 is in phase with channel 1, the amplitude has been maximized. And in another hand, whenever channel 2 is out of phase with compared to channel 1, then the power has been minimized. Here is the major scenario. Whenever we change the phase of channel 2, okay, destructive and constructive interference happen. That's why the power has been going down and going up again. This the test result really is greatly to reflect the phase difference of channel 2 and channel 1. The same idea can apply to channel 3 and channel 4. Then we will have a full in-phase calibration table. With the result here, actually you already have a calibrated beamformer. That means whenever you turn on the system and you change channel 1, 2, 3, 4 to the phase step accordingly, then you have an in-phase system. This is a great opportunity and a great setup to help a student to understand the principle behind beamforming. So here's the video for live demo. Lab 1, what is channel gain? So we adjust the gain step and observe the power being measured. So here's the setup. We feed the PO signal into B board, and the B board will conduct the signal to the power detector. Here is the setup in real life. The PO will output a 28 GHz signal into B board. The B board will conduct the signal into power detector. So when we change the power step or the gain step, then you can easily to observe the measured power has been going up and down. Lab 2, what is constructive and destructive interference? Here's the basic theory. When two signals get in phase, that's maximized. Out of phase, then it's minimum. Let's get it into in phase again. Here is the setup. Again, PLO feed the signal. This time, we will emit the radio out of the antenna. So from the transmitter and receiver, we separate them to 16 centimeter. So the path loss out of air can be calculated easily. And then we measure the power. So here, if we turn on channel 1 and channel 2, and we change the phase of channel 2, and now we change the phase of channel 3 to observe the destructive and the constructive interference. And then we do the same thing on channel 4. So with the experiments here, basically we calibrate B board, and here is the calibration table, the result. Next, we do care about link budget. The link budget is a basic fundamental concept for IP engineer. That is easy for a single antenna scenario. However, that is a new stuff when we are using phase array or array antenna. So our developed kit offers a great opportunity to help students understand all this behind. Lab 3, now we can do beamforming. We can synthesize our beam based on the theory. And you can verify the theory with the setup here. For example, at the beginning, we form the beam in 0 degree, and then we can do 30-degree beam steering and measure the maximum power in 30 degree. TMYTEK, we realize how important of beamforming technology for 5G new radio. That's why we provide and we build up the platform for R&D and the educational purpose. Introduce 5G mmWave R&D platform. First, let's look at what is a typical 5G mmWave communication system looks like. Here is the architecture or the block diagram from baseband to intermediate frequency and to RF front end. All these pieces consisting of 5G network and 5G communication system. RF front end mainly consists of beamformer. The beamformer consists of an antenna array for high gain to overcome path loss. Also, PA and the LNA are integrated in one module. Of course, we also need a phase array phase shifter to control the phase of each radiant. TMYTEK, we invested and then we built up the beamformer system we call it B-Box 5G. B-Box 5G integrated all PA and phase shifter in one unit. This excellent system for antenna research and the 5G protocol developers. It's a ready-to-use system. You can do beamforming right away. It's out of shelf. It's available. Next important component is frequency conversion. Frequency converters bridge in between RF and IF domain. So we also build a frequency converter UD box to support 5G new radio FR2, the full band frequency conversion. We built in local oscillator, and that's the very first device to support a full FR2 band from 24 to 44 gigahertz RF. With a B box and a UD box, you can connect the system to virtually every baseband around the world to implement your protocol and to realize your prototypes. Introduce TMYTEK 5G mmWave product. From the system communication system block diagram, yes, beamformer definitely is an important component. So introduce beamformer family. This is a B-Box Lite. We can perform 2D beamforming with 4 IF channels. This is great for antenna designer, and system designer, even algorithm or protocol developers. B-Box 1, we do support 16 RF channels. And this is great to emulate the base station. Again, that's great for antenna designer, system developer, and protocol designer. Here is the comparison table for a whole family. Beamformer family support 28 and 39 gigahertz for both B-Box Lite and the B-Box 1. And all models support plus minus a 45-degree beam steering range. And this is the GUI provided by TMYTEK. As you can see, a very intuitive and a convenient to use GUI has been built up already for you. Easily, you can control each channel independently. And you can even customize your antenna and drag the beam through this intuitive UI to control the beam direction. The software application programming interface, we do support LabVIEW, C#, C++, MATLAB, even Python. So most of popular language are supported. UD box, it's a frequency converter we built for 5G new radio. It's an ultra broadband 5G NR mmWave frequency converter, covers up to 44 gigahertz. We have single and dual channel, 2 version, 2 models. Applications. Let's look into the real applications implemented by our customers. We hope this will give you some idea and to inspire your creativity and innovations. First, we believe our system is great for antenna designer. The antenna designer can test with a different patch design with different materials and connect to our B-Box through cable. That means you can have hundreds of designs and test the beamformer and the beamforming characteristics with a single device. Here's a real example comes from our Korean partner, Krimo. They do design a very special antenna for smartphone application. Before adapt the solution to real smartphone, they tested the idea based on our B-Box. This is a very classic design and application. Next, we believe the whole system, UD box and the B box, and connect with SDR, is definitely a comprehensive platform for protocol development. With the B box 5G and the UD box 5G, virtually these were compatible with all baseband. So protocol and communication engineers can easily to test and validate their protocol based on the platform showed up here. This is a real example from University of Hawaii. The team implement the protocol of mmWave radar based on the SDR and connect the SDR to our UD box and feed the signal to the mmWave beamformer. With the architecture here, the team successfully detected the syndrome of the COVID-19 patients. So that's the system to realize a non-contact vital signal detection for COVID-19. Here are more examples and more results from the team. With a mmWave, the wavelength is great to detect the breathing the features. So with signal process, the breathing pattern can be easily identified by the system. This is also a very interesting example is from North Carolina State University. The team built up an ultra-fast channel sounder. The idea is to replace traditionally the horn antenna and the gimbal. With the help of the B-box, so electronic beam steering can do really need to speed up the testing and to speed up the channel sounder to 15 times faster than the solution they had before. Also, the system and the platform is great to upgrade base station emulator. With the help of UD box, you can upgrade the sub-6 GHz base station emulator into mmWave band. And with the architecture showed up here, you can really do the signal testing with the 3GPP protocols to talk to a real smartphone. Hi, my name is Ethan, the co-founder and the VP of TMYTEK. Hi.
Okay. The video is close to the end, and sorry for the Wi-Fi disconnection. We will demonstrate the last solution for you. And thank you for watching the courseware video. Today we will show you base station and user equipment emulator. Before we start the video and live demo section, please type your question at the in-call message as the screen shows. If you have any mmWave questions, please we will answer the questions later. Then let's move on to the live demo section. The video section.
Here, we are going to show you how CallBox and UE SymBox work with each other. They both have operating at 3.5 GHz. The goal is to upconvert the signal to mmWave 28 GHz and to see what can we do in mmWave. As you can see here, both CallBox and UE SymBox generate 3.5 GHz signal. We use UDBox to upconvert from 3.5 GHz to 28 GHz. We feed 28 GHz signal to this device, which is emulated as UE, and it transmits the signal to the other side. The 28 GHz signal is received by another device which is used to emulate base station, then downconvert to 3.5 GHz. Now we are simulating the communication in the FR2 band between user equipment and base station, and to investigate the potential problems. The throughput that we are working with is 54 MHz and it is based on FR1 protocol. Amarisoft will launch the FR2 protocol and we have much higher throughput based on it. Talking about the communication at 28 GHz, we can take a look at this device. This is BBox. It stands for beamformer box. BBox Lite transmits the signal at 0 degree and it's received at 0 degree by BBox 1. Theoretically, if we shift the direction of the beam, we will lose the signal. We manually change the angle of the BBox Lite, which is the transmitter. From the display, we can see that throughput has dropped since the beams are not facing each other anymore. The throughput gain goes back to normal when the beams match. Here, TMYTEK provides a solution to upgrade frequency 1 to frequency 2 band. The solution is based on UDBox, BBox, CallBox, and UE SymBox. Thank you for watching.
Okay, then let's move on to the live demo section. Welcome Ethan Lin presents the solution of spectrum monitoring.
Thank you. Hi, I hope everyone can hear my voice clearly. All right. Thank you, everybody. Good morning. It's my pleasure to have you to join this meeting. And thank you for your time and pay attention to our webinar. Now it's live section. So here, as you can see, we prepare a live demo for you. First, I'm going to introduce the setup today, and then we will get into a live demo. First, let's check out what we have on the desk. We have a signal generator. That's from Keysight. The signal generator, here we go, will produce the waveform, necessary waveform, and feed into BBox 1 in 28 GHz. Okay, and then mmWave signal will be transmitted. Okay, there's somebody is typing. Okay, here we transmit the signal over the air to the horn antenna. The horn antenna will then transmit the signal, conduct the signal to UDBox. UDBox will then down-convert the signal to baseband or to lower frequency. Today, we are using a spectrum analyzer, as this black box shows, to analyze what we received from a BBox 1, that is transmitter side. Okay, so here, this architecture has been used commonly in operator or government regular detection to check the spectrum if there is any unnecessary or unwanted spectrum has been covered by the operators to each other. Okay, And here's the result from the TV. Let me introduce the GUI here. Here is the spectrum, the real-time spectrum analyzer. The spectrum analyzer continuously analyzing the signal received by home antenna. And the target band is in sub 6 gigahertz. So as you can see the spectrum here, all right, somehow it shows some 0101 nature, but because that's a waveform has been modulated by signal generator. Okay. And this GUI has been built up by TMYTEK. The GUI here is used to control B-box. So that's how we can control the beam direction. We can move the beam direction to any direction as you want. So this is a very innovative and intuitive way to control a mmWave beam. Also, we are the very first company to build a tool, such a kind of tool for you. Okay, so let's check out what is the effect. So when we move the beam to somewhere else, okay, the signal received by analyzer comes to flat. That means that there's nothing there. So this really proves the beam direction has been changed. And then we move the beam back to 0 degree and the signal is coming back. Okay, so let's zoom out a little bit. This is a short and straightforward live demo to show how this platform and the capability of TMYTEK we can help you. So actually, we certainly understand mmWave technology is new. So that's why we build a very good tool. We like to help you to conduct your research and R&D activities. My name is Ethan, the co-founder and the VP from TMYTEK. I hope this webinar section and the live demo really helps you. Thank you for watching today, and please let me know if you have any questions or you are focusing what kind of research or what is your application. Any questions are very welcome. Thank you.